The Raspberry Pi can only send a signal of 3.3 volts and of limited direct current. Larger voltages or larger currents will destroy the Raspberry Pi. Yet, the world is full of higher voltages. Lamps, motors, and other household appliances all take more than 3 volts. So, how do you bridge from the Raspberry Pi to the real world? The answer is transistors.
Hi, I'm Mark Neiman Ross, and welcome to this week's edition of Raspberry Pi Weekly. Every week, we explore the Raspberry Pi and share useful tips.
A transistor is a semiconductor device that allows a small current to control a large current. Perfect for what we need. And I recommend watching Use a BJT Transistor as a Switch from the Electronics Foundation Semiconductors devices in this library. There is a complete parts list included as a handout in the example files. You'll need some basic transistors, resistors, a small motor, and a solid-state relay. The handout includes a schematic for connecting these demonstration circuits. I've built the 3 parallel circuits to show different concepts. When everything is connected, turn on the power to the Raspberry Pi. Then run the Python program called control5volts.py. As the program runs, the LED will flash, the motor will pulse, and the light bulb connected to the SSR will also flash. So let's talk about what's going on in front of us. First, the simplest circuit, the one with the LED, doesn't use a transistor. Instead, it just connects from the Raspberry Pi to the LED. We don't need a transistor in this circuit because we don't need more than 3.3 volts. The LED isn't going to draw more current than the Raspberry Pi can safely supply. Now let's look at the second circuit. This involves driving a motor, which is not a good idea to do directly from the Raspberry Pi GPIO. Plus, the motor requires a signal greater than 3.3 volts, something the Raspberry Pi can't do. To isolate the motor from the Raspberry Pi and to control the 5-volt signal, I've used a 2N3904 transistor. The base of the transistor is connected to the Raspberry Pi, and this is what turns on and off the signal. Think of the base of a transistor as a switch that allows current to flow from emitter to collector. The motor, also known as the load, is connected between 5 volts and the transistor collector. With a transistor, we can safely control a small motor. Now, what about controlling a larger voltage, say house current? The 2N3904 transistor in this circuit is only able to handle about 40 volts. After that, it explodes or melts. We could use a larger transistor, but that would require more current. Instead, we can take the same circuit we used for the motor and control something called a solid-state relay. A solid-state relay can handle 380 volts and 10 amps, possibly more depending on the device. The one I purchased indicated it would switch on at 3.3 volts DC, and I assumed I could just connect it to the Raspberry Pi GPIO. The signal light on the SSR, solid-state relay, would light up, but there wasn't enough current to actually activate the device. So to supply more current, I took the same transistor circuit I used for the motor and connected it to the SSR. Now I have enough current to drive the solid-state relay and control a lot of voltage. So in short, transistors are cheap and easy ways to protect your Raspberry Pi from large voltages while controlling those voltages.
Thanks for joining me for this episode of Raspberry Pi Weekly. Be sure to join the LinkedIn group and check out previous episodes on LinkedIn Learning. I'll see you next week with more Raspberry Pi adventures.